Assalamualaikum to Sir Azdi. Today, we are going to be presenting about our MAT263 assignment, Application of Linear Combination. Our group consists of me, Muhammad Arman Baijan, and Ikwan Haikal, and we are from class CS1124E. In this case study, we were given two questions. Both are polynomial questions, and the second question we can use it in a real-life situation. The problems require us to use high-level thinking, and with the help of past studies, we are able to understand and solve the questions. Let's start with question 1. Find the cubic polynomial whose graph passes through the points -1, -1, 0, 1, 1, 3, and 4, -1. From the question, we know that the equation will be in cubic polynomial, so the equation will be px equals ax cubed plus bx squared plus cx plus d. The question has already given out four coordinates. With the use of these coordinates, we can substitute x into the equation to find the value of each point. As we need to gather all the value for each variable, we can substitute each x to get a system of linear equation. We will have four equations to begin with. The first equation is -a plus b minus c plus d equals -1. The second is b equals 1. The third is a plus b plus c plus d equals 3. And the fourth is 64a plus 16b plus 4c plus d equals -1. We will use elimination and substitution to get our answers for A, B, C, and D. The first step is to plus the first equation with the third. And since we know that D equals 1 from the second equation, we can substitute the value of 1 into D, and after we add these two equations together, we will get B equals 0, and that becomes our fifth equation. The next step is to insert the fifth equation into the third equation. Substitute both values from B and D that we got from the previous equations, and we will get C equals 2 minus A, and that becomes the sixth equation. The next step is to insert the fifth equation into the fourth. The same thing happens here with inserting B and D into the equation, and we will get 64A plus 4C equals -2, and that becomes the seventh equation. The next step is to insert the sixth equation into the seventh. Substitute the C from the sixth equation with 2 minus A, and we will get that A equals -1 over 6, and that becomes the eighth equation. For the final step, insert the eighth equation into the sixth, and we will get C equals 13 over 6. Since we know that A equals -1 over 6, B equals 0, C equals 13 over 6, and D equals 1, then the px will be -x cubed over 6 plus 13x over 6 plus 1. And finally, for question 1, this is the cubic graph obtained from the px equation as it passes through the points -1, -1, 0, 1, 1, 3, and 4, -1.
Now, for question 2, it is relating to the real-life situation, which the following table shows the lifting force on an aircraft wing measured in a wind tunnel at various wind velocities. Model the data with an interpolating polynomial of degree 5 and use that polynomial to estimate the lifting force at 2000 feet per second. Since there are 5 variables, we came up with an equation polynomial of degree 5, which is Px equal to A naught plus A1x plus A2x squared plus A3x cubed plus A4x power of 4 and plus A5x power of 5. The velocity presents as x in the equation. Thus, we substitute all the x according to its own value, which is the lifting force. This is shown to bring out the system of linear equation. Hence, in this slide, we can change the system of linear equation in the matrix form Ax equals to b. We did this to make sure we can find all the values for each vectors. It is much easier to calculate in the matrix form Ax equal to b since the matrix size is way too large, which is 6 by 6. Hence, calculating manually or using elementary row operation will take a longer time. Thus, we use Cramer's rule to determine each vector's value by substituting the constant into each column of the matrix. First, we find the determinant of the original matrix. Throughout the calculation, the matrix will be reduced to row echelon form. Hence, we can find the determinants of triangular matrices for the original matrix. Using the website called matrix.rashish.com, we found the determinant value. And to find the vector of A naught, we substitute the first column with the constants. Hence, with using the same method, we can divide the original matrix determinant with the first column constant determinant. Thus, the value of A naught is found. Same goes for the second column. We substitute the constant into the second column and find the determinant for each matrix. Then divide it again with the original matrix determinant. Hence, the value for A1 is found, which is negative 5.86072226. Steps are repeated for each of the columns substituted with the constants b. Now we can see it, which is the determinant for A2 is negative 4.24135.169. Now, to find A3, the steps are similar, which is we divide the original matrix with the constants b, and thus the value is found again for A3. The technique used for A4 is the same, hence we get the result of negative 0.032309. And for the final vector of A5, we can conclude that the answer is negative 0.0005433. And with all of the information gained, hence, we can use the original equation that we had used earlier, which is Px equal to A naught plus A1x plus A2x squared plus A3x cubed plus A4x power of 4 and A5x power of 5. And we know that each of the vectors A naught, A1, A2, A3, A4, and A5, thus, we can just substitute each values into its designated order. But since the question asks us about the lifting force at a velocity of 2000 feet per second, we can substitute x with the value of 20. Thus, the equation can be calculated since all the values are found. At the end, We have found the answer for the question, which the lifting force at velocity of 2000 feet per second is equal to 206.9489. To make sure the answer is guaranteed, we also use a program code called R language, since it can handle a large numbers and the results can be found almost immediately. It is the process of finding the variables. Just a little to no coding. The answer is similar to the answer we had used earlier, which is 206.9489. Since these two answers are the same, we can conclude that the answer to the question is correct. Overall, both questions were solved using linear algebra. The first utilized methods like back substitution and elimination method to find variables for plotting a polynomial cubic graph. The second demonstrated a real-life applicability by using matrices to analyze values, with assistance from R language for computational efficiency, ultimately determining the lifting force on an aircraft at 2000 feet per second velocity. This case study underscores the broad utility of linear algebra across various domains, enhancing both computational skills and problem-solving abilities in everyday life. And that's all from us. Thank you.